This remarkable object is one of the oldest surviving images of the night sky, showing the moon in 1857, not long after the process of photography had been invented. It's a beautiful, fragile and wonderful thing, but what it represented at the time was a spectacular breakthrough in technology.
Since then, we've come a long way. For the past 50 years, we've been sending spacecraft around the solar system. And they have been sending back the most amazing pictures.
On tonight's programme, we'll be revealing our choice of the 5 most stunning images ever taken of the solar system.
We'll be investigating why these images were taken and how they've transformed our understanding of these alien worlds.
Welcome to the Sky at Night.
Appropriately enough, we're at the Natural History Museum's Other Worlds exhibition, a collection of spectacular images of the solar system. What's stunning about capturing images like these of other bodies within our solar system is that it would have been inconceivable just one generation ago.
Over the next half hour, we're going to bring you remarkable and striking images from all over the solar system. And we've chosen what we think are the 5 most significant, based on 3 criteria.
Firstly, scientific interest. Each image needs to reveal something about our solar system, how it works, or its history.
And secondly, they need to represent a technological advance, a new way of seeing the solar system.
And finally, of course, each image needs to be absolutely visually stunning.
There are literally thousands of images we could have chosen. But we've settled on what we think are the top 5. We start by considering images of Saturn.
Saturn has always been considered to be the most beautiful planet. And since 2004, the Cassini space probe has been in orbit about it, and it has sent back some extraordinary pictures. And our choice for the iconic picture of the Saturn system is this breathtaking portrait of the planet and its rings. To explain the intricacies of this stunning image, I've been joined by Cassini Imaging Team scientist, Carl Murray. Carl, this is an extraordinary image of the planet Saturn and its rings, but there's so much here. Can you guide me through?
Well, it's actually 141 different images all mosaicked together, but taken in a very special geometry when the Sun was eclipsed by Saturn. So we are in the shadow of Saturn. The spacecraft is in the shadow of Saturn when the image was taken. So what we see is a kind of a unique view. We can see, for example, this bright ring around the planet, which is the sunlight being refracted through the atmosphere. We can see the main rings themselves, and we start to see these other rings, which are normally almost invisible to see. But this geometry with this alignment with the Sun allows us to see these faint rings and learn something about them.
Yes, they seem to be so far out beyond the planet that it's just a huge system.
It is. In fact, this whole image is covering about 600,000 kilometers across. So it's so there's the planet, which is about 60,000 kilometers across, and then this vast main ring system here, and then these faint rings going out beyond that.
There's all sorts of colours going on here. Now, is this real data, or is it a sort of artificial colour?
The differences are real. So, for example, the main rings you see, we know composed of water ice. We've known that for some time, so you would expect that to be, well, essentially white. But there's some contaminants in the rings as well. So there's a slight reddishness to the rings, which combined with the water ice gives a sort of yellowish colour.
But the photo reveals more than just the rings. Elsewhere in the image, we see several of Saturn's 62 moons. And the photograph also reveals how the formation of Saturn's rings and moons are entwined.
This is the moon Enceladus. So this is active. We think there's liquid water, possibly even a global ocean of liquid water underneath. And this material is coming out at pressure and going out to several hundred kilometers, and then just sort of wandering around. If you just look up really closely, you can actually see the plumes of material coming out of the South Polar. And that has created the entire E-ring. So it shows this connection between rings and moons.
Yeah, and it seems to be quite a strong one. So sort of moons forming rings, and then sometimes rings forming moons?
Yes.
I find that surprising.
I did too when it was first proposed, but we know that material kind of naturally kind of accrete in the rings. Supposing you get a large enough mass, then it could start evolving as it interacts with the ring material around it, and maybe even escape from the rings, and then move outwards, and then maybe catch up with another one that had already escaped and get larger. And they originally proposed it for small moons, and they think not. Maybe even the larger moons of Saturn and indeed other giant planets could have formed in this way. So that rings can lead to moons. If moons break up, they can lead to rings. And it's a very interesting process that goes on.
Far more dynamic than I ever realised.
Exactly.
Now, you have this sort of, what I like to call it an accretion disk with a large mass in the centre. That all sounds very familiar.
Yes, it's funny you should say that. It's very similar to what we think the early solar system was like, that there was a disk of material out of which the planets formed in that case. And this is a disk that we can study in detail now, and we can see how things evolve now, and then try and extrapolate to what went on in the early solar system.
So by studying the rings of Saturn, we can actually look back to the formation of our whole solar system. Well, I think that makes this an incredible, powerful picture, because not only is it beautiful of Saturn, but it's giving us an understanding of our very own origin. Well, thank you. That was fantastic.
You're welcome.
Before we leave this astonishing photo, consider the technology that was used to take it. Cassini's black and white camera has a resolution of just 1 megapixel, a fraction of what you'll find in the average smartphone. It's only by stitching the photos together and applying filters that isolate particular wavelengths of light that it is possible to make these astonishing colour images. Art and science, both served by the power of technology. Our next photograph moves beyond art and science to touch the deepest human emotions, and it was captured by a camera even more primitive than Cassini's.
I'm remarkably lucky to be holding this thing in my hands. It's a flight spare, a copy of the cameras that flew on the Voyager 1 mission, one of 2 spacecraft that were launched in 1977 towards the outermost planets of the solar system. It's the same technology that was used in the first video cameras, and although it looks rather primitive now, the Voyagers produced some of the most spectacular images we'd ever seen. As the Voyager probes flew out through the solar system in the late 70s and 80s, they sent back amazing pictures. There was detailed video of Jupiter and its immense red spot storm, and the first close-up images of Jupiter's moons, revealing Io to be volcanically active and Europa's icy surface to be covered in mysterious stripes. The probes flew past Saturn and then became the first to photograph Uranus and Neptune. But we haven't picked any of those images. Instead, we've chosen one taken on Valentine's Day 1990, a time when Voyager 1 was more than 6 billion kilometers from the Sun. And, at the suggestion of the famous planetary scientist Carl Sagan, it turned to look back in the direction from which it had come, and it took this image. And at first there's not much to see. You see the blackness of space, a couple of streaks which are glare from the sun on the lens. Sun must be up here somewhere. But if you look closer, you see this tiny pale blue dot suspended in one of those sunbeams. And that is the Earth, seen floating on its own amongst the blackness of space. And no one caught the emotional impact of that realization better than the man whose idea the picture was.
And this is where we live, on a blue dot. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives on a mote of dust suspended in a sunbeam. The earth is a very small stage in a vast cosmic arena.
Our third picture was taken 25 years after the pale blue dot, by the next mission we sent to the outer reaches of the solar system. Last summer, after a 9.5-year journey, the New Horizons space probe began its approach to Pluto, a world many expected to be frozen and featureless. Until then, our highest resolution images of the dwarf planet had been little more than a fuzzy dot. Now we were getting increasingly detailed pictures. And on the 14th of July, New Horizons made its closest approach as it flew past Pluto. For the mission scientists, there was a nervous wait to see what, if any, images had been captured by the spacecraft. One of those scientists was Carly Howitt.
It felt like being 5 again, and it was Christmas morning, and you knew that there were presents. But until you actually see what's inside the box, we didn't really know for sure whether the exposure times that we'd set were right and all those sorts of things. So we were confident in our abilities, but you're always a little bit nervous. So once we started getting the data on the ground, we knew it was safe and we knew it was good. And it was like Christmas morning over and over and over again.
Our third image is this spectacular picture of Pluto taken by New Horizons. The dwarf planet snapped suddenly into focus, and it was unlike anything that had been expected.
This image really revolutionized the way that we understood Pluto. One of the first things that we saw in this image were the mountains. There are mountains of water ice on Pluto. Now they stand about 2.5 miles high, which for a water ice mountain is incredibly high. We wouldn't get that on the Earth. Water ice wouldn't be strong enough, it would collapse under its own weight. But at Pluto's cold temperatures, it's strong enough to maintain that weight.
On closer inspection, some of the mountains held even more surprises.
They have holes in, and you only get holes in mountains if they're volcanoes. And so what we think is going on here, these are cryovolcanoes. So not volcanoes in the way that we're used to them on Hawaii with hot rock and lava, but rather volcanoes that would have emitted ice. We don't see them being active now, we don't see any outflow from them at the moment, but we don't know when they were last active. But there's certainly enough sort of strange terrain around them to indicate that they must have been active in the near recent past.
But while some areas of Pluto were rugged and mountainous, in others, such as the large heart shape, Tombau Regio, the ice was suspiciously smooth.
The left side is known as Sputnik Planum, and this is a very interesting region because it's incredibly smooth. But when we zoom in, you can see there's a lot of complicated structure in this region, and you can see there's all of this structure in the cells itself. But you can see how different this terrain is when you kind of get up against the bedrock, if you like, the sort of surrounding regions. Now, the smoothness is very strange. Everywhere is bombarded by meteorites, these called impact craters. And so what is going on in this region of Pluto to eradicate those impact craters? And there's several ideas about this. The prominent idea is that this is made of mostly nitrogen and carbon monoxide ice. And these are quite soft, and so we don't think that a lot of heat is needed in order to get these ices moving. And we think that the heating that Pluto still has from its core is able to circulate these ices. So if you had an impact here, it wouldn't take long before this overturning sort of eradicated any evidence for it. So this image really has revolutionized our understanding of both Pluto and the outer solar system. Before we got there, we knew something of its bulk composition, but we didn't know about its complex geology, and we certainly didn't think that it was geologically active. This has huge implications not only for our understanding of Pluto and its evolution and its composition, but also for other similar bodies in the outer solar system.
Before we reach our next photo, let's delve back into the history of our attempts to photograph the solar system. We've only been sending probes to the planets for 50 years. But as Pete Lawrence has been finding out, the art of astrophotography is much, much older.
The technology found in digital cameras today has come directly from astronomy. In fact, the sensors, like the one I'm using here, and the ones found in digital cameras and smartphones, are descended from those developed by NASA for interplanetary spacecraft.
And the desire to take pictures of the sky has a long history in helping develop photographic techniques.
In fact, even before they were taking photographs of people, photographers were taking pictures of the sky.
The earliest photographs, called daguerreotypes, were taken on chemically coated sheets of copper and developed using mercury fumes. However, these weren't very sensitive and could only capture the very brightest objects in the sky. So photographers and astronomers came up with a series of new techniques. I've come to the observatory's Science Centre in Hurst-Monceau, where astronomers have been imaging the sky for 150 years to try out one of those old techniques. This is Guy Patterson, an artist who specialises in historic photographic methods.
Hi, Guy.
Hi.
Nice to meet you. This looks quite interesting. What's going on here?
We're going to attempt to get a shot of the moon using a very old process called wet plate collodion.
Right. So what have you got to do then to make this work?
Okay, so we're going to start off by, I'm going to put on these protective gloves because silver nitrate tends to stain anything organic for several days if you use it. We have our plate. It comes with a protective film over the surface we want to use. So we're going to peel that off. So I'm going to pour on the collodion.
Okay. It's completely away from the sanitisation of using digital kit where you just press a button and the image appears on the back of it.
That's right, and I think that's a lot of the appeal actually. You're completely in control of the situation. If it goes well, you are. Right, so now we're ready for it to go into the silver nitrate solution.
Okay.
And we lower it in there carefully. That makes it light sensitive after that point.
I guess the lights have got to go out now so that we can get the plate onto the back of the telescope and try and capture a picture of that moon, which is shining brightly out there. Perfect for us.
5, 4, 3, 2, 1. And here is our plate. Nothing to see at the moment. Now we're going to develop, which we do just pouring this solution on.
So this takes about 15 seconds, you say?
That's right. Just stop the development by pouring water over it. Finally.
It's the moment of truth. Oh, look at that. So now you've rinsed it off, is it okay to turn the lights back on?
Yeah, it should be absolutely fine.
Okay. This is amazing, and just how it used to be done. I mean, the plate is actually quite small, but when you look at it closely, you can see there's loads of detail on it. And to be honest, I'm actually quite surprised that this old technology is able to produce something as sharp as this. Quite amazing.
So far, we have seen 3 of our 5 images. A portrait of the whole Saturn system, a distant view of planet Earth, and a revolutionary image of Pluto. Our next image may seem plain by comparison. It's a picture of Gale Crater on the surface of Mars. But this photo is special because it shows with incredible accuracy what it would be like to stand on the surface of another world. It was taken by one of the most advanced pieces of equipment we've ever sent into space. The Curiosity rover that was lowered onto the surface of Mars in August 2012. Amongst its suite of scientific instruments, Curiosity is equipped with a camera mounted on a mast at head height. This particular image was created by painstakingly assembling more than 70 frames from that camera into a single high-resolution panorama. The colours have been adjusted to render them as close as possible to what our eyes would see. It is the work of artist Michael Benson.
So this is sort of a human eye view
Yep.
of the Martian surface.
Exactly, and what I'm trying to achieve with a lot of these images, most of these images, is to give people a sense of what it might look like if we could actually go.
So why is it important to let people see images like this?
You know, I think that we on Earth spend a little bit too much time in our kind of self-absorbed concerns, you know. I would submit that it might be very useful if we looked up a little bit more and understood that that the Earth belongs to a suite of landscapes orbiting the same source of light, the sun, you know. Some of them very alien and sci-fi, you know, Jupiter or Jupiter's moons and so on. And some are very close to what we might see on, I mean, they're very Earth-like in some ways. This one, for example, it looks like Utah, parts of Utah or Arizona, you know, and so you can see this connection between Mars and our planet. I mean, those are the so-called terrestrial planets.
Yes.
Those with hard surfaces in the inner solar system. And so that's part of what I'm trying to convey with this work.
So this could be Earth, but it's not. This is another planet out there.
But the sky gives it away, doesn't it?
Yes, that does look alien.
Yeah.
Well, I think it gives everybody an opportunity to stand on the surface of Mars, and to me that's a great achievement.
Thank you very much.
Thank you.
I appreciate it.
But as awe-inspiring as this picture is, there's a great deal more to it than its aesthetic appeal. The primary purpose of imaging the planets is to provide scientific value. And in that one image of Gale Crater, there's an amazing wealth of detail about the geological history of Mars. I've come downstairs in the museum to find Dr. Joe Michalski, a planetary geologist who uses images from spacecraft to study the geological past of Mars. So when I look at this image, I see a landscape and I can imagine being there. But as a geologist, what do you get from images like this one?
Well, the first thing we think about is context. And the important thing here is that this is the floor of a huge impact crater. Those craters effectively are basins where sedimentary rocks accumulate from various processes.
Because it's an old impact crater.
Yeah, about 4 billion years old. And the rocks within it are also old, but 500 million years younger than that. So a lot has gone on there.
Okay, so what should I be looking at if I want to be a Martian geologist? Where do we start?
So if you look at the top of the image, that's the edge of Mount Sharp. You can see layered rocks that are nearly horizontal.
Yeah, there's this sort of stripiness to it.
Yeah, and so those are rock beds, strata, that formed probably through airfall of volcanic ash or dust. And that's accumulated over millions of years, and that's why it forms layers. Then beneath that, you can see there are these other units that don't form as prominent of topography, the bluish and the light brown. So the fact that it does not form these big buttes tells me that it's a softer unit. And so if we're able to investigate the mineralogy of that, it might be something that's, for example, contains clay minerals or sulfates. Those are minerals that formed in water, but they're softer.
So this is part of the evidence that there was some water here or some dampness here, is the fact that you have clay and these other things.
That's right. And then in between is this unit which is just composed of gravel and sand and dust. And those are common deposits on Mars where you've got a little bit of sort of fluvial activity.
That's river-like, right? Or water, is that
exactly.
right? So when we look at this image, we see a landscape partly shaped by water. And the crater's 5 kilometers deep. So should I be imagining a big, deep lake? Was the crater full of water?
As we've investigated this further, it seems that no, it probably wasn't ever filled like that. But certainly there was water here. There were small lakes that came and went at the scale of thousands of years. It seems like a lot to a human, but geologically, it's a snapshot.
It's amazing to me how much you can tell from this one image. But of course, that's the beauty of these images of other worlds. They're not just beautiful things to look at. They're data as well.
Yeah, that's right. Every single image is packed with scientific information.
Joe, thank you very much.
Thanks.
And that brings us to our last image, which is a bit different from the others because even I haven't seen it yet. It's only just been taken. Via this NASA webpage, I can access data from a satellite called the Solar Dynamics Observatory, which sits 36,000 kilometers away from Earth, staring at the sun and sending its data back. And this is its most recent image, taken just 10 minutes ago. And it's not the view of the sun we're used to. It's not a featureless yellow disk. This is the sun in the ultraviolet. The Solar Dynamics Observatory captures images using light in 10 different wavelengths. It reveals the sun to be a very different beast from the featureless golden disk we're used to seeing. It shows the surface to be incredibly active, bursting with flares and massive explosions of superheated plasma. This is the true face of our sun. I never get tired of seeing the sun like this. It's not just a boring yellow disk. It's a dynamic and active world. There are wonderful features in its atmosphere, and the disk itself is a turbulent, boiling mass of gas. And we can see all of that because we're looking in the ultraviolet. And that's one of the reasons we chose this image. It demonstrates that by going beyond the light that our human eyes are sensitive to, we can get much more information about the cosmos.
The Solar Dynamics Observatory actually images the sun once every 10 seconds, giving us a real-time view of the star that allows us to trace the source of its surface activity. In some wavelengths, we can see dark sunspots on the surface, but in other wavelengths, we can see that those dark spots are the sites for the greatest solar activity, where arcs of plasma burst from the surface along the twisted magnetic field lines of the sun.
And that's important because activity on the sun has a tremendous effect on the Earth.
The activity on the sun's surface creates what is known as space weather. The flares and ejections from the surface send streams of charged particles shooting out into space. If they hit the Earth, they create quite an effect, causing aurorae like the northern and southern lights. But those solar storms can also cause severe damage to the electrics of satellites and even interrupt power supplies on Earth. And that is why the Solar Dynamics Observatory images are so important.
It is hoped that the information embedded in these brilliant images will give us an understanding on the causes and variety of solar activity, helping us to predict space weather and finding out when solar storms are heading towards Earth.
So that's it. Our choices for the top 5 solar system photos. And if you think we've missed something, or if you disagree, you can use Twitter to let us know. But whatever your favourite image is, you can agree, I'm sure, that we've come a long way since this wonderful image of the moon, taken almost 160 years ago.
We really have.
And that's all we have time for this month. Next month, we'll be joined by Stephen Hawking to explore the recent discovery of gravitational waves and what they can tell us about black holes.
In the meantime, get outside and get looking up.
Good night.
From launch site to splashdown via the moon and beyond, space-themed radio dramas, readings and comedies available now on the BBC Radio 4 Extra website. Coming up, an edgy, darkly comic thriller featuring Kristen Scott Thomas, In the House on BBC 4 next.